Hi everybody, I'm Carlo Miano. I'm part of the Lynch Group, a small company grounded in 2023. It was grounded by three engineers, one of was me, with former experience in motorsport. So, and we wanted, the main scope of the company was to bring, some knowledge, some methodologies, some new technologies developed in Formula One, in motorsport, to the real world. And at the moment, we are a company of about 20 people. And, working for a real world, we have two main research projects. One is on the biogas production, so biogas plant. It is called Didimo. And so in the past, I was, obviously I was working in Formula One a lot as a system engineer. And, I worked many years on the energy deployment problem for a Formula One car. So we wanted to bring, to the biogas production, the same methodology, the same technology that were developing, during that time in Formula One. Another big project that we are working on is the design, also with the 3D printing technologies of a turbine that can recover power during expansion of expansion of fluid in frigid cycles. So other possibility that we have in Lynch is obviously we are still working for motorsport. We have, one of the main typical things that we have in Lynch is the possibility, obviously, to cross correlate the knowledge, of different people. We are multidisciplinary, and we are still working on, composite materials, especially carbon fibers. And at the moment, we are capable even to design a full racing car from scratch. The only thing that we are not dealing is the powertrain at the moment. So why biogas? So one of the main challenges of biogas processes are obviously that, especially the biogas production is non-linear and time delayed. Obviously, a typical cycle, if you change the input of a digester, it takes more than 10 days, to see the results. So it is quite a slow process. And the other thing, the other big challenge is that, energy prices are quite volatile, and they change, very fast, and also with insensible quantities. And the other big, challenge is that, most of these, let's say, plants are generally managed, with rule-based control, or even, by the input of operator. So, for example, one of the plant that, I will show in this presentation, it's a plant, anyway, quite small in terms of energy management. We are speaking about something like 700 kilowatt for solar panel installation, so not huge. And it's managed by 2-3 guys that are not doing only this job, but they are doing also in the meanwhile something else. That there is a lot of stuff to say. So the idea is to help this guy with improving efficiency and profitability of the plant. Consider also that anyway, the investment is not negligible in this kind of plant, with the modern predictive control. So the framework used was basically based on Modelica and model on impact, with the possibility also to run some simulation using Optimican and IPOP. What we were doing, and we are still working on that, is the orchestration of this optimization in a Python environment, in order also to retrieve, information from the web, regarding weather forecast, and also very important, also energy price that, could. So at the end, the outcome of this model predictive control is is anyway a techno-economical optimization, that's. So the plant model has, typically, okay, the energy purchase and sell. So, and, there are, for example, in this example, there are 3 battery that are producing solar energy. So, and also, obviously the load, the electricity load from the plant that is generally office, that is very small amount. And, the big demand is given by the motors that are mixing, the fluid inside the digester. The other thing is obviously the thermal load. The thermal load, because, digester needs to stay at a constant temperature close to 40 degrees in order to have, the best production of gas and the most efficient, let's say, window. It is also quite useful to consider also the digester as a thermal storage, because you have a big mass of water or something that is very similar to water. And, it is very, very important to accumulate energy in this. And, the management of this is very important also to improve the efficiency of the whole plant. Another thing, obviously, that, last but not least, okay, another part that is quite important is the cogenerator part. So, and typically it is very important to control properly the throttle of the cogenerator. And at the same time, you have some boiler, but these boiler are mostly used as a backup, just in case you have a failure on the cogenerator or you need to stop them for maintenance reasons. Obviously, we are speaking about very small plants, so a kind of small environment that probably will be reproduced also in Italy. This plant is in Italy, and the very good thing is it's very easy to have all the cost under control, all the information under control, and this is what allowed to us to create in a very short time a digital twin that is quite nicely fitting, also the expectation, So the control variables typically are obviously the energy purchase and sell, and also you see the partialization of the cogenerator, because obviously you have to consider that having the solar energy, you need to follow also the energy production with the cogenerator, considering what is the actual solar energy arrived in the battery. So obviously the main objective is minimizing the energy cost. And what we are doing at the moment, we are still experimenting the methodologies. We have a receding horizon that is updating every quarter an hour or every hour, the optimization in order to track as much as possible beyond the age in terms of cost optimization. So the other big activity that we are doing now, it is obviously the possibility to track energy price. So I was speaking about the possibility of orchestrating the optimization in Python, and then from the website, using specific API, you can obviously retrieve all the data regarding prices, energy prices, but also very important, the forecast like temperature profile, and also irradiation profile, that are very important to be able to track the result of the report. So just to show typical situation. So the first example is without constraining the the digester on having the same energy, okay? And what is possible to see is that, by changing, for example, looking to this scenario, by changing the selling price of the energy, you can find, via optimized control and, different pattern, different profiles that are very useful to, that are optimizing, the cost, the operational cost of the plant. So obviously, for example, in this case, in this typical use case, we consider 1 month. We have found that, if the price of the energy goes below 90 euro per megawatt hour, of the sold electric energy, you need to be in a very autarkic regime and, follow as much as possible what the sun, is giving to you. That's the other possibility. Obviously, the other threshold is, if the price of the energy goes above, 110 euro per megawatt hour, you need to go full throttle with the. In between, you need to do partialization, and this is a kind of warning, and this is what the optimal control continuously is trying to do. The other point is another target, also another very important point, because in the first case we didn't care about the energy, the thermal energy that is going to the digester, and without constraint. But in some situation, obviously, to keep the production on the edge also, it is very, very important to keep also this constraint fixed. So to use the energy, to have the energy accumulated in the digester always more or less constant. In this situation, you can see also that the pattern are changing a little bit and the strategy are changing, and also you see the threshold, in terms of energy price, and this is something very important that the optimal control should consider and follow during. So this was a kind of first step that we did, for this customer in order to convince him, to further invest in this project, and obviously they are very happy. So you have to consider that in reality, of the plant, it's not always running 100%, especially at the beginning where you are running and all these kind of things. So there were some time of maintenance or hours that need to be considered also in the final consideration and the final cost comparison. And what is very, very interesting that depending obviously on the energy, incoming energy on the plant, we were able to save always something around 7%, as in average 7%, but in some months could have been even higher. So at the end, the key outcomes I would say that are obviously reduce the cost in low price, especially in low price scenario, and also strong validation with versus real data. Obviously, what could even face and underline the customer the strategic value of thermal storage also. So at the moment we are still working on this project, and obviously this was a kind of concept work to demonstrate the customer that the idea is worth. At the moment, we are working a lot also on the infrastructure on the plant, so we are improving a lot the internal communication between various parts of the plant. We are also obviously creating a big database that can retrieve all the data and properly manage all the information coming from all the components of the plant. So another thing that we are working a lot is the digester modeling. You have to consider that at the moment digester are we have already some models, but these models are very complex and sometimes more suitable for scientific research. We are speaking of something about a 90 equation, to consider also the population of the bacteria population. But at the moment, we are trying to simplify also this model because some dynamics are very fast and are not really useful for, at least for engineering purpose and for the final target that we have. We are also making some experiment on hybrid integration of AI with the model of the digester for full AI based. Even if we had already some nice result on the hybrid approach, or at least the one thing that we are doing at the moment. So we are training the AI with the real with the simulation model in order to start to have already a AI network that is doing something sensible and also with a limited time, because obviously you need to wait to have all the data, you need to wait months, it is a very slow process. And then we are putting in parallel the neural network to the data and continuously retrain this neural network in order to improve also the AI model with time. So another important thing is obviously use the tool for predictive maintenance, especially at the beginning when you have the running of the plant is something that the customer requested, and it's very important for him. And obviously, in this case, we didn't have the chance, to participate to the design of the plant. But another important fact, as I can tell you, this was a prototype plant, so the first in a series of plant, and probably in the next one can be improved also by using simulation model and simulation. So at the end, conclusion, so the biogas plant, could be a viable solution for sustainable energy. And also you see the digital twin together with the MPC, improve the efficiency. And, we are, and also the very positive thing is that we were able to create a framework that will be probably, not probably, for sure used for other renewable system and scalable to other plants. One thing that is very, very important. So we started this project quite recently, so we didn't took too much time to get to this level and to be able to do a demonstration. We started from scratch, and in a very short time, by using Modelica and the available Modelica tools, we were able really to create a concept design of the model predictive control that the customer really appreciated. This is also, in my opinion, something also to be considering very, very useful in this case.